All right, I think we're good. Good morning, everybody. I don't know that I can see everybody in the back, so there's plenty of seats up front. I won't pick on you, I promise. So I learned something new today. So I learned that before you give a talk, you should always kind of coordinate with the keynote speaker, because I have somewhat similar of the same slides that she talked a little bit about, but hopefully we get around it and we can dive a little bit deeper into how it applies to Spring and into Quarkus. So show of hands, who is a Spring developer? It's kind of what I expected. Anybody using Quarkus? That's good. Anybody know how to spell Quarkus? A couple people know how to spell Quarkus. All right, so a little bit about me. My name is Deandrea. You can probably tell from my accent, I'm not Portuguese, although my heritage, I am half Portuguese, but this is my first time in Portugal, so I'm enjoying my stay so far. I'm from the US, I'm a Java champion. I've worked in financial services most of my career before joining Red Hat, but even before joining Red Hat, I've always been involved in open source, whether it was consuming it, building it, contributing to it. I was a long-time contributor to some of the Spring projects. I contribute to Quarkus. I have a deep dive, a 3-hour deep dive tomorrow on LangChain4j, which has a little bit of Quarkus, but is more focused on LangChain4j and AI that I'm doing with my my partner, Jan. So yeah, I do also run my local user group, the Java user group. Anybody go to their local user groups, whether it's here in Coimbra or wherever abroad? A couple people. I highly recommend getting involved in your local community. There are so many good speakers that come, and you can learn and network with your local peers and talk. It's a great experience. I highly recommend getting involved in it. And like I said, I help organize the one in Boston. So I've also written this book about, and that's kind of where this talk came from, looking at Quarkus through the lens of someone who's familiar with Spring. And just to show a hand, so people are building applications with Spring. Who's building custom Spring Boot starters for Spring? One brave soul over here. All right. Two, three maybe. All right, so the majority of you are just using what's off the shelf and not building your own custom opinions around it. So I'm gonna try to talk a little bit about from the application side, but a lot of what I'm gonna talk about is from the perspective of someone who's either building libraries or building libraries on top of Spring. And if we look at Java in general, I know Holly hit on this a lot at the keynote. Everybody was at the keynote, right? Was anybody not at the keynote? So those of you who didn't raise your hands, where were you? Huh? All right, so Holly kind of hit on this efficiency thing in Java and containers and slow and why would we do that kind of thing. But if we start looking at and we're running applications, especially Java applications in containers, we're talking about getting your applications to the point where they're, and I'm going to say fully warm. And that doesn't mean just start it up and able to serve requests. It's, with the JVM, it starts up, you've got this high spike on load, but the just-in-time compiler over time takes time to kind of figure out what your application is doing and how to optimize the code. Because as your application runs for a period of time, the compiler, the just-in-time compiler will re-optimize your bytecode based on what your application is doing. And how long that takes really depends on the application, the environment, and whatnot. But the problem with that, especially in an environment, anybody running in Kubernetes? Yeah, we know how to spell Kubernetes? All right, awesome. So especially in Kubernetes, you start to think about, in the good old days from when I started doing development, you would give, anybody giving their Java applications 32 gigs a heap? More? 64? 128? Right? How many cores and RAM do you give it on Kubernetes? 1 core? So you can take a hello world application and you can give it 200 millicores and 256 megs of RAM, and you can make that thing take 10 seconds to start up. Or you can give it 10 cores and 100 gigs and make it start up like that, right? It's all based on the amount of resources. So the challenge we have in something like Kubernetes is, especially when you start talking about horizontal scaling, and for those that are familiar with Kubernetes, horizontal pod autoscaling and using Kita or any of those kinds of things that scale your applications based on different types of metrics, the faster your applications can get to whatever their highest SLA is, regardless of tech stack, the better, right? And for Java, that takes a while. So if you've got a burst, and because if you work in the retail industry, for example, you might have a burst of load, and if you have an old monolithic application, it may start up in 30 seconds, but it might take half an hour to get warm. And during that half an hour, Kubernetes may spin up more instances, right? And those instances may eventually spin up, and they look around and be like, hey, I've got nothing to do here. I'm just going to go away. So all your cluster is doing is churning instances and wasting resources, to kind of hit on that efficiency a little bit more. So kind of where I'm going with this is the faster that you can get to that warm-up period, the better you're going to be, regardless of your tech stack. And the slide I've got up here was a talk that Simon Ritter did a couple of years ago. If you're interested in how the just-in-time compiler works, I don't know a whole lot about it, but the first 15 minutes of his talk, he really focuses on that point here. And again, Holly kind of showed this a little bit too, but when we start talking about Spring and other highly dynamic frameworks, you've got this clear separation between build time and runtime. And it's pretty clear. You build your jar, war, ear, whatever you're deploying, and then when you run it, all the magical stuff happens. And in the Spring world, we talk about auto configuration. Anybody have a good understanding of how auto configuration actually works under the covers? A couple people. So you have all these classes that are annotated with @auto configuration or @configuration. You have all these methods with @bean that drive your beans, or anybody using like conditional on property or conditional on bean not exists. All these different variants that you can introduce beans based on what's actually going on. Well, how many times when you start your application, especially in a container, does what's actually going on change? Right? Because I know I could take an application with like Spring Security and I can run it on my laptop and turn security off, which is what we always do, right? Because that's what good developers do. And then when we deploy it, because we don't write any tests, we deploy it into an environment and maybe we do basic authentication. And then when we deploy it to production, we use like OpenID Connect and we connect it in, but we haven't changed any code. Is that a good thing? Is that a bad thing? It's highly dynamic and the framework allows you to do it, but just because you can do it, is it a good idea? Right? So when we start talking about these ephemeral applications, and especially in the container world, we're talking about applications that if you want to actually change the behavior of the application, which to me, that security conversation is a behavior, just because you can do it through environment variables doesn't mean it's necessarily a great idea. So we want to be able to do and move as much of that work to build time as possible. Not just to do the work, but kind of going back to that just-in-time compiler conversation. Rather than just generating bytecode, can't we generate just-in-time compiler data, in the format that the just-in-time compiler would use, so that when the application starts up, we can just kind of hand it over and say, hey, we've already done some of this work for you. So now you don't have to do all of it. There's still some stuff you got to do at runtime, but we can optimize most of the stuff at build time. Has anybody used the Spring AOT stuff that's out there? They introduced the Spring AOT library, not necessarily native image, but where it does the ahead of time compilation. Have anybody actually looked at what it does under the covers? A couple of people. So it generates a bunch of source code that then gets compiled. And the source code it generates, has anybody been doing Spring since XML configuration? Has anybody ever written a custom XML namespace before in Spring? So under the covers, there's a whole bunch of interfaces and code that you can write that actually generates your bean definitions programmatically. And the AOT code that's what it actually does under the covers. It generates source code so that your annotation processing and your annotation scanning is the order that it happens is deterministic, because that's part of the big thing that Spring at runtime is it's got to figure out what's the order, because different beans, you can inject one bean into the construction of another bean, and so it's got to figure out all the order of how things work. And so the Spring AOT library kind of does that at build time, where it'll actually generate source code that then gets compiled that determines what the order is. But all that code still gets loaded at runtime and loaded into the JVM at runtime. All the classes still get constructed at runtime. So it's moved some of the stuff to build time, but not a whole, not all of it. And then we have this native image. Anybody doing native image in production today? Anybody tried it? A couple hands. Is it a fun experience? No. So this native binary, and I don't want to harp on it too much, but essentially being able to remove the JVM. And so with Quarkus, this was a big thing when it first came out. Oh yeah, we can do native image, But in my own personal opinion, I find that this native image solution is a very small solution to a very small amount of problems. Like if you need instant startup and very low footprint, you're gonna run it on like a Raspberry Pi or some edge device out there somewhere. It's an awesome solution, but in most cases, I find we're all on the JVM, that we belong on the JVM, and Java applications belong on the JVM. So that being said, anybody using like Project Crack, CRAC, checkpoint restore, anybody familiar with it? Again, they shouldn't let developers name stuff, because you talk about drugs and whatnot. You don't even want to go there. But this Project Crack allows you to snapshot, run your application, get past the just-in-time compiler startup, and then snapshot your application so that you can get back to that point faster in time. And you can do that with Quarkus, but we don't really invest too much in it because we don't really have the problem to begin with. And so here's where I should have collaborated a little bit with Holly before doing some of these slides, because I actually stole some of these slides directly from her. So she and I collaborated a little bit on this. But if you look at like, what does it actually do? What's the secret sauce under the covers? So the first part, and I'm gonna kind of skip through the ones that she talked about, JTA auto wiring. I like to pick on Hibernate, for example. With Hibernate, even with Spring, there's lots of different ways you can configure Hibernate. There's Bean, you can do it through Beans, you can do it through configuration. Anybody still writing persistence.xml? So if you compile a Spring application, even if you're not using persistence XML, what's on your class path at runtime? XML parsers, right? Because Hibernate needed them to build its model, which in Spring World happens at runtime, even if you didn't need them. In Quarkus, we can see how you configured it, and then we can decide, hey, you don't need those XML parsers. We can just kind of throw them away so that they don't need to make it into your runtime artifact. The second thing that she talked a little bit about is this dead code elimination, being able to look at dependencies that are on your class path. So for Oracle, for example, you've got 500 or some odd classes that belong to your Oracle driver. Everybody has multiple JDBC drivers on their class path these days, right? Because you're gonna maybe go into different environments. Maybe you've got Oracle, maybe you've got Postgres, maybe in your lower environments. But if you're looking at, especially when you start getting into JPA, it's got to look through all the classes that it knows about that implement the JDBC spec and figure out which one to actually use. And that takes time. So again, another thing that is great to be able to be done at build time, even if you've just got one JDBC driver, you're the one that it looks for, it's got this static list of class names that it's got to try and load. Maybe the one you're using is last. And so it's got to go through this loop of try to load this, catch class not found exception, then go to the next one, try, and building exceptions and whatnot is expensive. Yeah, so that polymorphic binding that we're talking about. Okay, all right, so the other part of this is, okay, this is great for the core of the framework, having this process to be able to do these kinds of things, but it needs to be extensible so that other libraries and application developers can take advantage of it. Spring has the auto configuration stuff that people know how it works, but being able to provide this build system in place so that you as a developer can take advantage of, hey, if I need this thing that really should happen at build time, I can build that so that I can say, hey, these classes that might be on the class path, I don't need them at runtime, so let the build process eliminate things like that. And part of that is being able to do this index. People familiar with reflection and Java reflection and how that works and whatnot. So how does reflection work? At startup, your application starts up and all of your class metadata gets loaded and put onto the heap, right? And then whatever classes need to access it. But frameworks, specifically like Spring and these bean injection frameworks, what do they need to do? They need to find classes that are annotated with an annotation, or look through all the classes and find all instances of this annotation, or find all classes that are beans that implement some interface, right? The reflection package doesn't give you anything to be able to do any of that. I've looked, I've tried, it's not there. So what Quarkus does under the covers is at build time, we statically index all of that at build time. So it's available to your extensions at build time as well as your applications at runtime, to the point where that class metadata that's on your heap is thrown away at startup. We don't even need it. That's space that we don't need, because anything you need to look up in the class hierarchy is available as anybody remember O of n, O of 1 from your computer science classes? It's a static O of 1 lookup. right? All right, another one that maybe not so performance related, but more of a user experience thing, don't make people tell the computer what it already knows. So everybody's familiar with this, right? Right? Why? This just like bugs the crap out of me. Why? You already know what class you're in, right? So wouldn't it be better if you could do things like that and it just knew at compile time to do this, right? So take that work out of here. So take that pattern and extend it so everybody's familiar with Spring Data JPA, right? And the repository pattern and the repository interface has all of these methods that magically get generated at runtime for you. Well, why can't we do that at build time and apply this pattern to other things like that so that we can generate stuff at build time and pre-optimize it for you? Okay, I gotta make this faster next time. And then continuously profiling. So we have a whole team, I think some of them are here in the room, a whole team of engineers that are just constantly, like a millisecond is like an eternity to these folks. So like, hey, this version regressed by 2 milliseconds, something's wrong, we need to look at it, or maybe something's not wrong, but we need to look at it anyway. You know, continuously shaving and profiling and trying to figure out what the problem is. And kind of the last thing that I like to harp on is reactive programming. Anybody using Webflux or reactive programming? I get like 2 hands in the back. Yeah, that's kind of what I expected. So those of you folks who have your hands up, when did you have to make that choice of how to build your application? Before you wrote a line of code? Like before you actually, and in this agile world, before you knew exactly what you were building? So you had to pick the best application architecture, whether it was blocking, reactive, non-blocking, before you knew what it was that you actually had to build. So being able to provide a framework where it doesn't matter, you can mix and match and you can change over time. So if I want to write a class that starts off like Spring MVC, fully blocking, and I want to start introducing some new completely non-blocking methods into that same class, I can do that. And the underlying framework takes care of that for you. And then you've got the developer joy thing, which I'm going to talk a little bit about in some of my demos. But at the end of the day, it's still Java, and it's not having to learn all this new stuff. It's looking at the specs that are out there, you know, whether you're doing Jakarta RS, JPA, JTA, all these specs that come out of Jakarta EE, and adapting them to this build time optimization. So those of you, what if I told you that based on all of your Java that you're running out there today, what if you could run all of that but save half the cost? Or flip the other way around, the salespeople, like I tell them to block their ears when I say that to an audience because they don't want to lose revenue. But what if you could run twice as much for the same cost? That's kind of the glass half full perspective, right? After you've taken a nap and a shower and gotten re-energized and you're down to a 4-day work week, right? So that's what I'm gonna show here. Am I on time? Half an hour. Any questions so far before I go on to some code? All right, and I'm gonna apologize up front. I really hate light mode, but they said it didn't work in dark mode in the back, and I'm getting old, so I have to put my glasses on to see anything, but with my glasses on, I can't see anything out there, so I'm gonna be constantly doing this. So I've got an application here, and this application comes right from the samples in my book. So I've got a Spring Boot application. I picked Spring Data JPA because I figured it's a pretty general use case. A lot of people are doing Spring Data JPA. Anybody doing reactive with relational databases? It's kind of what I expected. I don't really find that people aren't using R2 DBC with like Postgres or Oracle or anything like that. I don't find that very often. So I have an application. I have my pom.xml, and apologies, my screen is like this big on my laptop here. Oops, I'm in the wrong branch. Sorry. I was in the wrong branch. All right, so now that I'm in the right branch, I've got a pom.xml that looks like a Spring application, right? And I'm gonna cross my fingers. Spring Boot 3.5 just came out last week, so I haven't actually tried this with Spring Boot 3.5, so I don't know what I'm gonna get, but hopefully I get the right thing. So I'm using Spring Data JPA, Spring Boot, Spring MVC, the validation stuff, the actuators. I'm using a Postgres driver. So I've got lots of tests in here because I like to write lots of tests. I've got my my main application class, which nobody ever touches except when you do a demo and you build your entire application in this class, right? I've got a entity class, just a Jakarta entity. It's pretty simple. I like to do it with fruits. I've got my Spring Data JPA repository class, and I've got a controller with a couple of methods on here, just a couple of gets and a post. Look, nothing out of the ordinary here. Everybody seems to be what it is. All right, so now if I go, I got to compile this, and we'll skip the test because nobody cares about tests, right? I have another talk for that, or I talk about test-driven development. So we compiled it. So when we do, I can't do like pure load testing here because it's like a cardinal sin if you do generate load and run the application under test on the same box. So I can't do load, but I can do like what would be an important metric? Time to first request, or the startup time that the application says it started up in. Does anybody trust that number? Hey, I started up in 3 seconds. Trust me, they all lie. Spring lies, Quarkus lies, Micronaut lies, they all lie. I like time to first request because some frameworks may be lazy. They start up really, really fast, but you pay a penalty on the first request. Other frameworks may start very eager, but that first request is really fast. And other frameworks kind of might be in the middle somewhere, might do some eager, some lazy. So I like time to first request, and I like to see kind of what the footprint is of that application after that first request as a good metric. In addition to max requests per second, but unfortunately I can't do that on a laptop here. So if I run this thing, I have a script which will actually do this test for me, which if I can just run it and I can pass in what command I want to run and how many times I want it to run, and it'll compute an average, because you always want to do it more than once, right? Because it could be an outlier at one end or the other. You want to do it more than once. Usually when I do this in a benchmarking environment, I do it 10 times, but for now I'm just going to do it 3 based on time that we have here. So if I run this guy, I'm going to do, the first thing I need to do is I need to start up a database, right? Because when we run our application, we need a database. So I'm going to run a Postgres database. And now I can say first request. I'll do it 3 times, right? Starts up. Boom, boom, boom. So the average was 2 seconds. So what did it say it started in? It says I can't scroll to the right, but that's all right. So I'm going to start keeping some notes here. I'm just going to go to the README file, and I'm going to keep some notes here. So Spring, time to first request, right? 2.137 seconds, and my RSS is the resident set size, so that's both the on heap and off heap, the total memory footprint of the application after when it computed that. So 444.2 megs. Does that sound unreasonable for those who have been doing Spring for a long time? That sounds pretty normal. Does anybody not think that that's normal? All right, good. All right. So we got that. So what about that AOT stuff that we talked a little bit about before? Does that help improve any of this situation a little bit? So if I compile this down and I say clean, oops, I gotta remember the command here. Here we go. So I compile it in AOT mode, and you'll notice what it does is it actually starts the application up a little bit, and it generates, if you look at what it generates in my target folder, it generated, I'm gonna refresh this, reload, Spring Data JPA, target, classes. So if you notice and I'm just going to pick something here, org Spring Framework, where is it here? Spring AOT, classes, or sources, org Spring Framework, boot. I'm just going to go into one of the, I'm going to pick something at random, auto configuration, Spring Data, JPA, some auto configuration class. So it generated all this code, which this one actually isn't very interesting, but essentially it generated this static class that has bean definition code. Has anybody ever written anything like this before? This is like really old school Spring, like from way before Spring Boot. But you can create these bean definitions, and this is kind of the first process that runs before your configuration classes will run. So when you build your own classes that say at configuration with at bean definitions, all this kind of stuff has already run before any of that happens, and then you can order them as well. So the AOT process generated all these source code and then compiled it, and now this stuff ends up in your archive so that it gets instantiated at runtime. So now what happens if I try and run, I'm going to bounce my database just because. What happens if I run this? Oops. I don't know what's going on here. My laptop is going crazy. There we go. So when you run it, you have to tell it that you want that AOT process to be enabled, right? So now I'm going to say Spring with AOT, time to first request, 1.932 seconds, and my RSS size of 412.8. So my application starts, what, 2 milliseconds or 200 milliseconds faster, shaved a little bit of the memory performance off. So that's what the AOT will give you. So when you compile your application with AOT enabled, now by doing that, you've essentially given up some control. You've given up the ability to dynamically switch some things at runtime, because now it's kind of captured a snapshot at build time of what your application looks like. So not completely closed world, but definitely more closed world than if you were just to run without the AOT processing enabled. All right. So now what about native? What if I do native compilation? So if I compile this thing, even clean package dash clean native compile, and we'll skip tests as well because we don't care about the tests. Right? So I'm going to do this native compilation. What native compilation does is it does the AOT stuff, right? So that's a requirement for doing native compilation. And then it's going to use, so I'm using GraalVM Community Edition on my laptop here, so Java 21. So it's going to take GraalVM and it's going to look at my application, and it's going to statically compile that down to a native executable. And in my case, I've got a Mac, so it's an ARM binary, so I wouldn't be able to take that binary and run it on Linux or run it on Windows. It's going to be specific to the AMD 64 architecture. And what it's also going to do is it's going to look through not just my code, but all the code of all of the libraries that I'm using, and it's going to do dead code elimination. So if there isn't a static compile link, i.e. reflection between two things, it's going to throw them away unless something tells it not to. Right, so a lot of what's out there in the Spring framework, like with the GraalVM and the Graal, what they call it, the reachability metadata, but it provides a whole bunch of stuff that Spring throughout the framework says, don't throw this away, please, which under the covers basically tells the whole framework not to throw it away. Because you can actually look at what it generates here. When it goes through, GraalVM will analyze the application. I don't have a pointer, but it'll analyze the application. And in this particular case, there were 39,690 classes, 84,337 fields, 280,621 methods. Of those, 11,147 of those classes were registered for reflection, meaning they did some kind of reflection and it had to tell the GraalVM compiler not to throw those classes away. Outside of those classes, there were another 2,000 or 2,100 or so fields that were in other classes where it didn't need to keep the whole class, but it needed to keep the fields. You know, you can think at autowired, like all over the place. So that, you know, kind of performance trick number one, stop using at autowired and use constructor injection, because you'll save some performance in this regard here. And I know the Spring team probably recommends that as well. It's something that I always recommend regardless of what dependency injection framework you're using. Constructor injection is way better for a lot of different reasons. Join me for a beer later and I can convince you what all the other reasons are. And then methods. So there's like 13,000, you know, estimating about 13,000 methods or so that it's registering for reflection. The application itself, the build process took 1 minute and 10 seconds. So my native build time was 1 minute 10 seconds. Oops. Seconds. My The build process for building native images does take some resources, and in this case, 7.3 gigs of heap space to actually do the native build. 7.35 gigs, right? And then the artifact itself is 148.25 megabytes. So that's our binary size, right? And then if I run some of these same performance numbers on it, let's bounce my database. And then if I run my, and you notice now there's no more JVM because it's eliminated the runtime from it completely. There's still, it's not entirely true. There's a little bit of garbage collection that still kind of happens, but for the most part, all things Java have been removed, which make things, there are tools for debugging, but it makes it a little bit more difficult to do debugging. It makes it hard to do, the just-in-time compiler is gone. So one thing you'll notice if you're doing this native compilation regardless of framework, if your application lives for a long period of time or runs for a period of time, that application on the JVM is going to get higher overall throughput than your native equivalent of it. And it's kind of just a fact of going back to the just-in-time compiler conversation. So now when I have my native app, my native time to first request is 0.664 seconds, and my native RSS is 143.7 meg. So significantly faster, significantly less memory usage. It's going to give me, if I could do throughput, it's going to give me probably half the throughput that I'm going to get in a production environment if I was using it on the JVM, because the JVM is going to do garbage collection and make it more efficient over time. All right? All right, does anybody disagree with anything I've done here? And I'm wearing kind of short sleeves so nobody can see that I've got magic up my sleeves here. So what I'm going to do is I'm going to do a little bit of surgery here. So let's get rid of all this other tabs. And I'm just going to go in to pom.xml. And I'm just going to delete it all. Right? And I'm going to replace it. And what did I replace it with? I've got the CertJ stuff, and I've got a bunch of Quarkus stuff. So basically, I've eliminated Spring from the application. I've noticed I've got this extension. So I've got a Quarkus Spring Web extension. I've got a Quarkus REST extension. I've got a Quarkus Spring Data JPA extension. I've got Hibernate. I've got my actuators. I like YAML config. I've got a Postgres driver. I've got some container image stuff. I'm using JUnit. I'm using Mockito. Still using a CertJ. We don't care about the tests today, right? Nobody cares about tests. But this application should actually still compile. So if I do a Maven clean package, skip test, not native yet. So this application should still compile. Nope, it doesn't compile. So why doesn't it compile? Oh, we've got this application class here that nobody ever uses, right? So this is like the best. So as a junior engineer, you're coming into work and you like write all this beautiful code, or you have the AI write all this beautiful code, and then you go to a code review and they tell you to trim it down, right? As soon as that pull request gets merged, you're like, yeah, I'm awesome. I've been doing this for 25 years. Trust me, code that I wrote 10 years ago is still with me, and I hate to maintain it. So every line of code that I can delete is like, you know. So now I can go through and I can delete this code. I don't need that class. I can also go in here and I can clean up a couple of things. So in my application YAML, where it tells it where my database is, I can change that a little bit. And so instead of Spring, it's Quarkus configuration, right? So now if I come back to that, it should compile. Nope, doesn't compile. Why doesn't? Oh, because I have tests that I didn't refactor. So Maven test skip. Nobody cares about the tests. That's a whole nother talk. We can talk about tests. All right, so now my application compiles, but I've still got the same JPA object, right? I've still got the same Spring Data JPA repository class, and I've still got the same Spring MVC controller class. I didn't touch any of my code. So what do you think is going to happen here when I start running some of these tests? And don't be shy. All right, so I already did that. So now if I start up my database, and then if I come over here and I do my first request, Java dash jar, oops. Oh yeah, because it's a different artifact. That would have helped. Target, there we go. That's the right artifact. Boom, boom, boom. Now where'd my notes go? My cheat sheet. All right, so now, oops. Where'd my README go? There it is, there's my README. All right, so now Quarkus JVM, right? Time to first request and RSS. Time to first request 1.024 seconds and RSS of 312.0. So that's, if we kind of look at the Spring version, so 1.0 versus, that's like half the startup time, right? 444 into 312, so it's way less, about a third, roughly, quarter of the memory usage. We can't really do the AOT comparison because Quarkus by default, it is AOT. So it's already doing all that for you automatically. So if we look at our, we now do the native compilation here. Dash P native. So now we'll do the native compilation. Quarkus native, build time, the build RSS, the binary size, and then we have our native time to first request and our native, I can't type, RSS. All right, so we can already see we've got 24,263 classes. So what was the Spring? Was like 30-something thousand? Does anybody remember? I'm terrible with numbers. I've got a bad memory. Is it 30-something thousand? 48,000 fields, 192,000 methods. I think the Spring was like 280,000 or somewhere in that ballpark. Look at how much reflection. 300 fields as compared to, what was it, like 1,000, 1,200, somewhere in that ballpark. 6,000 types and 6,000 methods. So the amount, just the design of the framework in the first place, we don't use any reflection. We go out of our way when we build the core framework not to use reflection, not to use things that aren't statically linked and compiled. We don't use Java lambdas because Java lambdas have overhead. It might be negligible, but a little bit here, a little bit there, a little bit there. When you start piling it all on top, lambdas have overhead because they're essentially anonymous classes at the bytecode level. So if you look through the Quarkus code, it might look like somebody wrote it with Java 1.4, but it's far more performant than it is human readable. And it's an argument I have with the Quarkus team all the time. I'm like, this is like so unreadable. It would be so much more readable if you would use the lambdas, but we don't. So now if I start my database up and I run this test again, and I didn't capture the 43 seconds to run this, 43 seconds. The RSS was 5.25, so same raw VM version, but we shaved 2 gigs off of the build process, and our artifact is, where is it, 86.44 megs. What you'll actually notice with all this Spring stuff, so the Quarkus extensions for Spring, it's doing build time adaptations. So at build time, if you were to actually put a breakpoint in your application at runtime, there would be not a single Spring class on your class path, because the Spring MVC controller class is being rewritten at build time to Jakarta RS. All the Spring Data JPA is being rewritten to plain Hibernate under the covers. The JPA entity class is nothing magic in there. The properties are different, so there would be no Spring context. There would be not a single Spring class on your class path at runtime. And so now if I run this, oops, already done. So my time to first request, 0.849 seconds, and it used 64.7 gigabytes. So 0.8, yeah, megabytes, sorry, not gigabytes. Like that, I wouldn't even be able to do that on this machine. That was a trick. You're just making sure you're also paying attention. Right. All right. So what do we think? Good, bad, indifferent? All right, so what does this mean? And so that was great to run on a machine, but anybody can say, hey, I have a machine that, it's not deterministic, it's not reproducible, and totally with you. So we run these benchmarks in our lab at Red Hat, and these are run on bare metal on a machine with 8 cores, 14 gigs of RAM, so pretty big and beefy machines, and we can essentially prove what I just talked about. So if we look at time to first request, about half the time. We look at in a native over here, about half the time. Why is this so slow? Throughput. So the throughput number, which is interesting, you can start to see that in the Quarkus for throughput, we can do about 4.6 times the amount of throughput per instance. So what that means is if you've got a Spring application and you need 4 instances to satisfy an SLA, with Quarkus you only need 1. That 1 instance starts up in half the time and uses half the resources. So when you come back to the question of how would you like to save 50%, it's actually, in theory, more like 75% of your resources, just based on throughput and utilization and whatnot. And so there's lots of numbers. These slides will be available. You can churn through the numbers. You can start to see about density as well, and my slide went too far. You start talking about density. Density means at its max throughput, how many instances would you need to satisfy your load, or how many requests per second per meg would you need per instance in order to satisfy your load. And you can start to see that the throughput and the density, meaning how many instances would you need, and you could start using that for like capacity planning. If I've got a Kubernetes cluster that has so many nodes with so much memory, and I know I have this amount of load, I can start to predict how many instances of my applications I might need to effectively satisfy that load. To speed up these animations a little bit. Wasn't the first rule about presentations, don't use animations? So yeah, so I kind of talked about this a little bit. So when you kind of put them on paper and you look at what the makeup of these applications, and these are exactly the same source code, right? I didn't change any of the source code. You can start to see that the Quarkus version of it, I guess is what you would call it, has just way less stuff. So what does way less stuff mean? I know that's a technical term, way less stuff. Less surface area, right? Less vulnerability attacks, less all those good things that your security folks keep talking to you about. Just way less stuff and less reflection, which is what costs you money when your application runs. And there's plenty of customers and other people out there that have talked about, some organizations have decided just to throw their Spring away and start fresh from Quarkus. Other companies have said, there's no ROI in rewriting anything, so we're not going to rewrite anything, and they just adopted Quarkus for new stuff. Like I said, there's plenty of these use cases where we've targeted specifically organizations that are running Spring that have seen the benefits of it. Yeah, and I think that's, Holly referred to as well this I don't know if she talked about the carbon impact, but we actually ran this experiment in Amazon where we looked at the carbon efficiency of frameworks and what does the framework play in terms of being carbon neutral and carbon efficiency. And we found that with Quarkus, first off, we needed a much smaller instance type to run the application. And with that, we could see that the Quarkus version ran about 2 or 3 times less carbon, or 2 or 3 times more carbon efficient, meaning it outputted 2 or 3 times less carbon efficiency. Now, how do you measure carbon efficiency? That is the link. You can go read the study and how it worked. Holly actually did that study in conjunction with some of the Red Hat performance engineering team. And so I guess now you're a believer. So if you want to get familiar with Quarkus and want to start, the Spring has the pet clinic. We have the superheroes. I'm the primary maintainer of this application, so feel free. It's a pretty comprehensive application suite of microservices. And thank you very much. So the slide should be there. If anybody has any questions, I'm free to take some questions. No questions? All right, well, thank you. Enjoy the rest of the conference.